Hello friends, I welcome you all in this session. In previous session we were discussing about multi-criteria decision making techniques, and we have seen the list of several MCDM techniques, and we did discuss goal programming also, and we also discussed analytical hierarchy process, that is called AHP. So, as I told you that in AHP you have got different levels. At the top level you have got the ultimate goal, and then there are several criteria. Each criterion can have multiple sub criteria and so on. So, in AHP we try to rank let us say different suppliers. If there are let us say 5 sites to be selected, then we will rank those 5 sites and so on. So, it is basically a prioritization tool, and we will look at couple of examples related to AHP now. So, let us say there are 4 projects P1, P2, P3 and P4, and we have to select one of these projects. And each project has got different quality levels, different price levels, different service levels and different delivery levels. So, we will solve this problem. Let us get started. So, first of all we will ask experts about their opinion on different pairs, and there are different pairs in this matrix. So, let us say the first pair is quality versus price, quality versus service, quality versus delivery. So, you can have different pairs, and we will ask experts to give how these criteria are important with respect to some other criteria. So, let us say if you are asking expert how quality is important compared to price. So, the expert said price is twice important than quality, service is 4 times important than service, the service is 4 times important than quality, and delivery is 3 times important than quality. Similarly, let us say this cell. So, here we will say that delivery is 2 times important than service. Now, when I say price is 2 times important than quality, in other words quality is 1/2 time important than price. When I say service is 4 times important than quality, I will say quality is 1/4 time important than service. So, the remaining cells of this matrix can be filled very easily. So, you need not get data from these empty cells. All these cells would be filled by just taking inverse of these values. So, here it would be 1/2, here it would be 1/4, here it would be 1/3, right, here it is 1/3, again 1/3 and 1/2, right. So, this is how you can fill the remaining cells or the lower triangle of the matrix. Once you are done with filling up of these remaining cells, what you should do, you just take the total of each of these columns. So, let us say this is 25/2. So, 1, then 1/2 plus 1/4 plus 1/3. So, you will get this value is 25/12. Similarly, for P and S and then finally D, right. So, if you look at total of this column, so 3 plus 3 6 plus 2 8 plus 1, so this is 9. So, just take the total of all these columns. The next step is divide all those cells by their respective total values. For example, divide 1 by 25/12, so it would be 12/25. When you divide 1/2 by 25/12, it would be 6/25 and so on. So, similarly you can divide all other cell values by their respective column totals. Let us look at how to find out weight now. So, after finding all these values, you just take average of all these points in this particular row. So, it is 12.25, 12 by 25, 6 by 11, 8 by 17, 3 by 9 divided by 4. So, you will get averages 0.457. Similarly, for delivery it is 0.105. Keep in mind that the weightage sum should always be 1, it cannot exceed more than 1. So, we will say that out of these 4 criteria, the most important criterion is quality, the second important criterion is price, third is service, and fourth is delivery, right. So, what we have done? We have done pair wise comparison amongst different criteria, right. Now, we will go for finding weights of different projects. Let us look at this. So, now we will go for pair wise comparison of different projects with respect to quality. So far what we did compare pair wise comparison of all the criteria with each other. Now, with respect to quality criterion, we will compare different projects. So, if you are asking to an expert how the quality of project P2 is important than P1, the expert says quality of project P2 is 5 times important than quality of P1 project. The quality of P3 project is 6 times important than quality of P1 project, and so on. The remaining cells can be filled similarly. For example, when I say P2 is 5 times important than P1, it means P1 is 1 by 5 times important than P1. If you look at this, this cell, P4 is 1 by 3 times important than P1, it means P1 is 3 times important than P4, and so on. Similarly, you just go for the totaling of all these columns, divide each cell value by the total of each of those columns, and then take the average, right. Similarly, you can do this comparison amongst projects with respect to price. So, whatever you did for quality, you can do it for price also, right. Let us similarly for with respect to service and with respect to delivery. So, you will have to get data from experts. How many times total? So, first of all, you would be collecting data on 4 different criteria, and then second time with respect to quality, with respect to price, with respect to service, and with respect to delivery. So, you will be taking data 5 times from experts, and if there is one expert, so he would be filling you 5 different questionnaires, right. So, let us find out the weightage for quality criterion, and this comparison is amongst projects, right. So, this is what was your initial data 1, 5, 6, 1 by 3. So, here I have just divided 1 by 3 and I have taken this value as 0.33, right. So, you can also do such type of calculation. After doing this, just calculate the total of each of these columns, 4 columns, divide this one value by 4.37, 0.2 by 4.37. So, you will get all these values after dividing. So, this is for P1, P2, P3, P4, and this is the sum of all these P1 to P4 just divided by 4. So, this is known as normalization, right. So, the highest, if you look at the quality criterion, the most important project is this is P4 0.56 because this value is highest. The next important one is P1, then P2 and finally this. So, we will find out the weightages of all these projects with respect to other criteria as well, right. So, this was for quality criterion. So, you can do it for price, right. So, for price again these are different totals, first, second, third and fourth. After finding out these values, you just divide the sale values by this total value. So, 1 by 4.29, 3 by 4.29, you will get these values, right, 0.23, 0.69, and similarly you can calculate other values also, and then finally take the average of first row, second, third and fourth row, right. So, with respect to price, which is most important project now, can you tell me? Yes, the most important project is P2 because the weight is 0.574. After this, the most important project is 0.30, right, then 0.075, then 0.046, right. Similarly, for other two criteria you can calculate these normalized scores, right. So, this is the complete weightages for all these projects with respect to all those criteria. So, for quality you got this, for price you got these weights, for service you got these weights, and for delivery these weights. And this is very simple, I think you can easily calculate. Now, once you are done with this, you are also having the weights of criteria initially what you calculated. So, 0.457 was there for quality and 0.105 was there for delivery. Now, which project is to be selected at the end of the day? Now, for this what you should do, you have got these weights for each of those criteria. So, 0.457 multiply it by 0.297 by this value. Similarly, 0.457 this weight of quality is to be multiplied with this weight of project P2. Similarly, 0.53 is to be multiplied by 0.457 and 0.457 is to be multiplied by 0.563, right. So, this way you will be getting the total weight again is 0.325. So, weights here is it is the multiplication of all this plus and you can divide it by 4, right. So, it is 0.325 for first project, for fourth project 0.294. So, finally, which project you will be selecting? At the end of the day you would be selecting project P1, right, because it has got the highest weightage. The second number project would be P4 project, then P2 and then finally P3. So, this is how you can solve any question related to AHP. And as I said, AHP has got multiple applications, whether you are selecting different sites for your manufacturing plant, you are selecting a supplier from several suppliers, if you want to, let us say after engineering or after doing any degree, if you want to go for, let us say, job, or if you want to go for higher studies, or if you want to start your own business, isn't it. So, there are different options which you can select for your future work, right. So, you can apply AHP in that case also. So, let us look at another important MCDM technique, it is called TOPSIS. It is the full form of TOPSIS is technique of order preference by similar to ideal solution. This is also a technique which gives you ranking at the end of the day. Similarly, what we have seen in HP ranked different projects, right, and we selected finally in HP, this was our selection, right, P1 project was our final selection. So, in TOPSIS method also we can select one of the projects out of several choices, and it has got several other applications. So, this method considers 3 types of attributes. So, you will have some qualitative benefits, you will have some quantitative benefit attributes or criteria, and you have got cost attributes or criteria. Let us see what these criteria are. For example, if I say I am making a, let us say, a product, so I would always like to minimize cost of the product, right. So, that can be one of the criteria. Suppose if I want to maximize profit, then that would be again one of the criteria. So, what we do generally in this method, we come up with 2 artificial alternative solutions. The first solution is known as ideal solution, and the second one is negative ideal solution. When I say ideal solution, it means all attributes are at their best levels. So, let us say if I want to maximize my profit, I want to increase reliability of the system, I want more and more quality, right. So, all of those would be at their best levels. When I say negative ideal solution, it means the one which has the worst attribute values. So, it is a solution which is completely opposite to your ideal solution, right. So, let us say if P is let us say P is P plus, the negative solution would be P minus, right. So, that kind of situation you can think of. So, what we generally do in TOPSIS, it selects the alternative that is closest to the ideal solution and farthest from the negative ideal solution. So, that is the principle of TOPSIS method. So, what are different input to TOPSIS? So, you have got different alternatives and different criteria. So, you can have m by n matrix. So, you can have, let us say, 4 alternatives, 3 criteria, 5 alternatives, 4 criteria, and so on, right. So, you will have Xij would represent score of opinion I with respect to criterion j. So, you will have an m by n matrix. So, let j be the set of benefit attributes. Benefit attributes means those attributes which you would like to more and more, which you would like to maximize. For example, let us say again profit, you want to maximize efficiency, you want to maximize, let us say, space utilization, is not it, and j dash be the negative attributes. It means you would like to minimize them. For example, you want to minimize cost, right, you want to minimize conflicts in the organization, you want to minimize waste, is not it. So, you can have several negative attributes also. So, there are a couple of steps in TOPSIS. The first step is we normalize our decision matrix. So, whatever data you are having initially, you are supposed to normalize. The reason for normalization is because your input data would be having different units. So, at the end of the day, you would be coming up with non-dimensional attribute for each of those criteria or those attributes. Then after normalizing matrix, you are supposed to multiply that particular matrix by its weightages, and the weightages would be given by experts. So, multiply each column of normalized matrix by its associated weight. The third point is determine the ideal and negative ideal solution. As I said, what is ideal solution? Ideal solution is a solution where all the attributes are at their best levels, and negative ideal is just opposite to ideal solution. So, these two solutions move in exactly opposite direction. Calculate the separation measures for each alternative. So, we will calculate separation measures for ideal solution as well as for negative ideal solution. In fact, these things would be clearer when I will teach you an example. Then finally, we calculate relative closeness to the ideal solution. So, this is the relative closeness would always be between 0 to 1. So, this ratio of negative solution, negative ideal solution divided by sum of negative solution and positive ideal solution. So, select the final answer which is closest to 1 or which has got highest value. So, let us look at this question. We would be applying TOPSIS method to this particular example. Let us say there are 4 different cars, Civic, Saturn, Ford and Mazda, and you have to select one of these cars, and there are 4 criteria on which you would be selecting these cars. So, you have got style, you have got reliability, you have got fuel economy and you have got cost, and these are the weights given by experts to each of these criteria. So, we will say that the most important weightage given by experts is 0.4, right. So, this is your input matrix, right. So, now let us move towards applying TOPSIS to this particular example. So, this is a case of 4 by 4 matrix, because there are 4 car models and you have got 4 criteria, right. So, what would be your benefit attributes? The benefit attributes would be what you would like to maximize. You want more and more stylish car, you want more and more reliable car, you want more and more fuel economy, right. So, these are known as benefit attributes, right. And let us say Z dash is set of negative attributes, right. So, you want something to be less and less, right. So, you would definitely like cost to be less and less, right. So, this is how you can have 4 by 4 matrix. So, let us first of all normalize the matrix, right. For normalization, what you need to do, you just take the square of those values which are there in your initial matrix, take the sum of all these columns, all these 4 columns. After this, just take the under root of these values, right. So, this 15.17, 14.46, 16.52 and 15.17, right. So, the next step is divide each of those values, divide each column by this value. So, let us say how you are getting this 0.46. So, initial value in this cell was 7, right. So, divide 7 by 15 by 15.17, right. So, how did you get this value 0.61? What was the original value here in the very first matrix? It was 9, right. So, divide 9 by what? 14.66, right. So, you will get this value, right, 0.61, right. So, this is how you can get your normalized matrix, right. Very simple, just a simple arithmetic. Now, once you are done with this process, the next step is you need to get weighted normalized matrix, right. So, just multiply the previous matrix by its weights, right. So, 0.1 is to be multiplied by 0.6, 0.4 by 0.4 by 0.246 and so on, right. So, this is how you would be getting your weighted normalized matrix, right. Once you are done with this, determine ideal solution. And what is ideal solution? Ideal solution you would like to choose where all these style, reliability and fuel economy are having their best values, right. So, for style the highest value is 0.059. So, write this value over here. For reliability the highest value is 0.244. For fuel the highest value is 0.16, and since you want to minimize cost, so you need to select this value, the least one, right. So, this is your ideal solution. Similarly, you can have negative ideal solution, right. So, select the least of style, least of reliability, least of fuel economy and maximum of cost, right. So, write all those 4 points. So, these are your negative solution, these two are your positive ideal solution and negative ideal solutions, right. Then find out separation matrix from ideal solution and separation matrix for negative ideal solution, right. So, this is again a simple one. So, this value is there, this is for negative solution and let us say this is for positive solution. So, 0.046 minus this whole square, 0.053 minus this whole square. Similarly, for this how would you write? 0.144 minus 0.162 whole square, right. And in this way you can calculate separation from ideal solution. This is a very simple arithmetic, right. Similarly, separation from negative ideal solution, but before that let us write what is the total of all these rows, right. So, this is how you can calculate the total and then take the under root of that value, right. So, this is total of all these values, right. So, this is your separation from ideal solution, right. Similarly, you can have separation from negative ideal solution. It is the same approach you have to apply, right, and then you can have separation from negative ideal solution, right. Now, what we need to calculate? We need to calculate ratio, right, ratio of what? Negative ideal solution to the sum of negative plus positive ideal solution, right. So, this is the ratio for Civic, it is 0.74, this is the ratio for Saturn, this is the ratio for Ford and this is the ratio for Mazda, right. So, which car would you select at the end of the day? Civic car, right. Why? Because this solution is closest to the ideal solution and farthest from the negative ideal solution, and this value is highest in this particular column, right. So, you would be selecting Civic car. So, I hope that you would have understood TOPSIS method, and if you can apply the same method for any other example also, right. So, similarly you can have let us say four vendors, you can have different criteria, for example cost of the product, delivery time, credit period, quality and so on, right, and this is how you can get solution to the other problem as well, right. So, let me summarize what we did in this session. We did an example on AHP and we have also solved TOPSIS method. We just took an example and we solved it using TOPSIS method. So, with this let me complete this session. Thank you very much.